Hello everyone. This is Rashid Kibria from Fix Research, University of Florida. In this demonstration, I will try to analyze a complex CPU core. This time, the CPU core is openMSP430, which was taken from opencourse.org. It is a complex open source RTL benchmark. This RTL I tried to analyze using Intel's Quartus Prime, but all the control FSMs were not detected and extracted perfectly. But RTL-FSMx is able to extract all the control FSMs from the RTL design of openMSP430. This is a very complex RTL design because, as you will see, the state transition graph is quite complex and so big, especially one control FSM present in the RTL. Just get started. So I will first find the tool. You can find it inside this RTL category. The first task, you have to add the RTL dependency file, and you can find that inside this openMSP430 folder. Here dependency, and there is a single dependency files which actually includes or contains all the define statement type things. So this is basically a something like a macro file which is required by compiler for pre-processing. RTL-FSMx internally uses PyVerilog, which is an open source Verilog HDL compiler. It generates the abstract syntax tree from that, analyze the AST using source code analysis, basically the static analysis, and extracts the control FSMs from there. So I will add this dependency file. Next, I have to add all the RTL designs. You can find it inside this RTL folder, and I will select one after another. There are now lots of files here. So, and also the RTL is very big because the total number of line count is very high. And I click on open, and it will add all the RTL design files. Next, you have to load the tool. There are basically two versions of the tool, the V1 version and V2. I will first try to analyze it using V1 version. I hit open and it will add the tool, and finally I click the extract control FSMs button. It will start executing RTL FSMs, and you see the control FSM extraction process is very fast, and all the control FSMs have been detected. So just to look for those. So here we see 1, 2, 3, and 4. So there are basically 4 control FSMs present in this RTL design. So I will show you one after another. The first FSM was detected inside OMSP_BBG module. And here you see the clock pin, reset pin, the state variable, the state vector representation, the implementation model, which was used to describe this control FSM, and also some other relevant information. The states present in the RTL, and also the FSM input signals and the control signals generated by the control FSM. You can see its corresponding state transition graph in text format, and you can find here. So this state transition graph is showing you not only the state transitions, but also why such transitions happen in this in the description. Let's look for another complex FSM. This UART module FSM, that was another thing. It is also not that much complex because it is a simple UART module for this openMSP430, and we see the similar type of FSM extraction report here. We can also find its corresponding state transition graph, and that is here. So you get all the states along with their state transitions conditions as well. Now, just focus on the control FSMs present in the front-end module. This front-end module of this openMSP430 core is basically the the main execution unit for the entire CPU core. If I click on it and hit open, it will show you the FSM extraction report. This one is the FSM extraction report, and you see all the state encodings, the state encoding style, and the other relevant information of the control FSM. If I try to visualize the state transition graph of it, yeah, you see this state transition graph is a little bit more complex. It has lots of conditions and lots of state transitions. Another FSM was this 2. It was actually present in the same module. This control FSM was not detected by interest quarters prime, but RTL-FSMx has successfully detected it and extract the control FSM perfectly. So if I go to its state transition graph, if you look here, it is so much complex and also so much big. It has a huge number of state transitions. As I have already mentioned, interest quarters prime cannot analyze very complex FSMs. So this is another demonstration of it, but RTL-FSMx can handle it, and not only that, but also extract successfully all the states, their transitions, and the transition conditions. Now I will try to run the V2 version of the tool on it. So if I click on it and hit open, and I hit the extract control FSM button, it will just take a bit time for the tool to be loaded, and after that it will analyze all the RTL designs. Finally, will provide you the FSM extraction report. Yeah, so you see, it is only within 2.87 seconds. In total, it extracted the control FSM, and the compilation part, the compilation runtime was also included in this 2.87 seconds. Now just look for the state transition graphs here. So I will first show you the second strategy of the control FSM, which was not extracted by interest quarters prime. So this control FSM is present in the front end module, and it is basically the second control FSM there. It is the execution unit. So you see there are lots of transitions and also lots of states here. This one is one strategy. Another strategy is here, the first strategy for the front end module, and this control FSM was extracted perfectly by interest quarters prime. There were no issues, but the previous control FSM was not detected even. So yeah, that is the thing. And if I click on another control FSM, that is these UART modules. So this one is the state transition graph for the UART module of openMSP430 code. And the last control FSM here is the debug module strategy. And yeah, it is also a very simple control FSM, and the FSM extraction report is here. So the state is shown in a light blue color. That is basically our reset state, and all the other states are actually your normal state. That was a quick demonstration of RTL-FSMx on a complex CPU core openMSP430. Thanks for hearing.